Welcome to Quadratic Functions and Transformations. Today we're going to look at graphing functions in quadratic form and how to transform them. And the transformations are going to include translations, which we slide left or right, up and down, and compressions or expansions where we stretch or shrink a graph as well. Okay, so a couple things we need to define. A quadratic function is a U-shaped graph, which we call a parabola. A parabola is the graph of any quadratic function, and it can be written in standard form. F of x equals ax squared plus bx plus c. There are other forms that we can use, such as vertex form or intercept form, but here in standard form from largest power to smallest, okay, that is called standard form. And again, be sure a cannot equal 0 because you would eliminate the quadratic term and you'd be left with something linear. So the other thing we have to talk about is vertex form, and that's going to help us with our translations and transformations today. Vertex form of a quadratic function is f of x equals x minus h squared, that quantity squared, plus k. Again, a cannot be 0. And the vertex is hk. Now the vertex of a parabola is where the parabola changes direction, either going from decreasing to increasing or from increasing to decreasing. A parabola will have one vertex. Okay, it'll change direction once. So that's important to know, and the vertex is found by looking at the h and the k value here. Okay, so the axis of symmetry. The axis of symmetry is a line. It can be vertical or horizontal, but for now we're going to look at the vertical line. It divides the parabola into two mirror images. So kind of thinking like drawing a line down your face, okay? You get the same thing on both sides. They're mirror images, okay? So the axis of symmetry has a vertical line of x equals h. Okay, and this is for the vertical. It changes if we talked about horizontal parabolas, but that's much later in the year when we get into conic sections. Okay, so what we have here is the general parent function in red of a quadratic equation. That's y equals x squared. There's been no compression, nothing being added, nothing being subtracted. It's the general parent function. It's the simplest form of a quadratic function. Okay, so we would call that the parent function, and here's our graph. It does open up because a is positive, and you can see the axis of symmetry is actually the y-axis, and it cuts our graph into two equal pieces. Okay, please note that the vertex is the point in which the parabola changes direction. For the parent function, there is no h value being subtracted with x, there's nothing being added, so we look at the vertex as being 0, 0. Again, this is where the parabola will change direction, so we go from a negative value into a downward slope here into a positive. When we change that direction, that's our vertex, is at the origin. Okay, so let's look at our first problem. The first problem is asking us to graph f of x equals 1/2 x squared. Again, nothing being subtracted with x, nothing being added out here. So in step number 1, I'm going to plot the vertex, and I'm going to draw the axis of symmetry. What's really nice is, if you know the h value of your vertex, you also know the axis of symmetry. The axis of symmetry will always go through your vertex. So the vertex here is 0, 0. There is no h, there is no k. There's our 0, 0. Okay, we're going to plot the axis of symmetry going through that point. In orange, it's actually the y-axis. Step number 2. You have to plot 2 points on one side of the axis of symmetry. Now, you can do that differently. What I personally like to choose is a point to the right and to the left of the axis of symmetry, and I try to do it by 1 unit. Okay, that's just very easy to do no matter where the axis of symmetry is. Pick a point immediately to the right and immediately to the left, and we can graph that. So I've created a table here to plot these 2 points on one side. So I pick 0, I pick 2, and I pick 4. 0, I plug into this function. I get 1/2 of 0 squared is 0. There's my origin. Okay, there's my vertex. If I plug in 2, I get 1/2 of 2 squared. So 2 squared is 4. Half of 4 is 2, so I plot 2 over 2 up. Okay? And when I pick 4, I have half of 16, which is 8, so I go over 2, or excuse me, over to 4, up to 8. So then I have 2 points here to the right, and they get directly copied across the line of symmetry. So you have 2 over 2 up, so you go negative 2 over and 2 up. 4 over on the x, 8 up on the y, 4 to the left, 8 up on the y, and you can see this is a mirror image, and it should be with this axis of symmetry. Okay, so a couple things to note. I knew that the parabola would open up because the a value is greater than 0, and we also know that there's no vertex, so the vertex is at 0, 0. And I shouldn't say no vertex. There's no h and k present, so they're both 0, 0. So let's take a look at a compression here. The last example, we showed that compression where we had a half. A was equal to 1/2. So here's a couple things how A affects a parabola, or excuse me, affects the quadratic equation. We have a reflection when A is negative. So here in red was the positive y equals x squared, the parent function. If we change A to negative, it's the same thing, but a reflection over the over the x-axis. Now, if we make A greater than 1, you get what's called a stretch. Okay, when we think about a stretch here, we think about the graph narrowing because we're getting larger a value or larger y values more quickly. So we call that a stretch, and you'll see that the parabola would actually narrow as a gets larger than 1. When a is between 0 and 1, we call that a compression. It actually widens. Okay, it takes longer for the y values to grow, so we have a much wider, slower growing parabola here. And notice how they're all opening up in this second and third part because the a value is greater than 0, or excuse me, greater than 0, so it's going to automatically open up. But you don't see a stretch until you see an a value greater than 1, and you only see a compression when a is between 0 and 1. And a lot of kids think that a compression happens when a is a fraction, but if I did 10/3 as an a value, well, that's larger than 1, so it would still be a stretch. So be careful, it's not just a fraction. The number, if a is between 0 and 1, that's when you know you're going to have a graph that compresses. It gets wider. Okay? So let's look at another example. Now, in this problem number 2, we're going to graph the function, a translation of f of x equals x squared. There's 2 examples here. So we're translating. That means we're going to slide left or right or up or down. Now, we try to make this a little bit easier here and just do 2 different examples, one going up and down, one moving left and right. In our first example, our function is equal to x squared minus 5. Well, now, compared to the original, we're subtracting 5 from this function. So every y value is moving down 5 units. Notice how nothing in this example is being subtracted with the x. Okay, like it is in the second example here. You see how the 4 is with x. Over here, 5 is being subtracted from x squared, so all the y values go down by 5. So it's important to know we're going to shift f of x equals x squared down 5 units. This means that k is negative 5. The x values here will not change because you're just dropping off the y values. So in red is the parent function of x squared. So what I do is I take the vertex. The vertex is no longer 0, 0. It's 0, negative 5. Remember, there is no h value here. So we drop that 5 points down, and we take a couple other points off x squared and drop them 5 units down, 5 units down. For example, 1, 1 becomes 1, negative 4. Negative 1, 1 becomes negative 1, negative 4. And we plot the smooth curve. In our second function, we see that h of x is equal to x, the quantity x minus 4 squared. Nothing's to the right. Okay, we're just subtracting with x. So the x's here are going to change, and we're moving right 4 units. Notice how this is subtraction. we're taking away 4. Taking away 4, so h is actually positive, so we're going to move right, not left. You got to think when you affect x here, whatever the sign is, whatever the operation is, you're going to go the opposite way. So it's a subtraction sign, we're going to move right. So in red is our parent function. And so we're going to move all these points 5 units right. So 1, 2, 3, 4, 5. So the new, or excuse me, 4 units. So 1, 2, 3, 4. So our new vertex is 4, 0. And I move all of my points from x squared 4 units right. So if you're at -1 here, -1 plus 4 is 3 for the x. Here we're at 1. And we're going to move this point 4 units to the right, so that becomes 5 and 1. The y values will stay the same here. You're just moving x's, all of them 4 units to the right, and here's our new function. In our last example, we're looking at graphing a vertex form quadratic, and notice how now I have an h and k, and I have an a that's other than 1. So upon looking at this, number one, you want to identify all your constants and see how they are affecting your graph. Well, a is -2, so that means a is less than 0. This parabola has to open down. H is 1, k is 3. Notice the operation, subtraction, but my h value is positive. K is positive here, k is positive here. So here are my 3 values. So I've identified the constants. Step number 2, I'm going to plot the vertex, which is hk, which in this case is 1, 3. So I plot 1, 3 here. Next, I'll draw the axis of symmetry through that vertex, and I've drawn the vertical line at x equals 1. Step number 3, I'm going to plot 2 points. So here's my trick. I just pick a point to the right and to the left. So I picked 0 and 2. Those are 1 unit away from the vertex on the right and left. I plug 0 in, I get 1, and when I plug 2 in, I also get 1. Now think about the line of symmetry. If the axis cuts this directly in half, mirrored image, if we're 1 unit to the right or 1 unit to the left of the vertex, they should have the same output. So when I plug in 2, I get 1. When I plug in 0, I also get 1. Because they're both the same distance from the vertex, they have to have the same output to be a mirror image. So I connect my graph with a smooth curve. Okay? So if you guys have any questions, please feel free to email me or comment below. Thanks, guys.